So what is a iterator? So generally, iterator is a function to create the iterable sequences. Okay. For example, I have a list. Okay. That list we can convert it to the iterator by using iter function. Okay. We can create iterators by using iter function. Okay. Iter function. So any sequence we can convert into iterator. Okay. So what is the use of iterator? So these are memory efficient. Okay, memory efficient, and it is having lazy evaluation. Lazy evaluation. What does it mean? So memory efficient in a sense, it will take the less memory compared to other objects. It will take the less memory, and based on the demand, it will give the values that we can call as a lazy evaluation. Okay, how it will get the values? We have a method called next. By using next method, we can get the values based on the demand. Okay, based on the demand. Okay. Let's see with example. Let's say I have a list. It is having values like this. Some random values. So how we can check this size of the list? There is a method called render method size of. Okay. So what it will return? It will return the size of this list. Size means how much memory is occupied for this particular list. Okay. Let's run. See, this is the 152 bits is occupied for this list. Now, the same list I can convert into the iterator by using iter function. Okay, by using iter function. Let's say L1 iter L. Okay. So what will happen now? Whenever we convert the sequence to iterator, so it will store the object reference instead of values. So it won't store all these values, but it will store the object reference. Based on the demand, whenever we call the next function, it will return one value at once. Okay. Here, creating iterable iterator. You can say iterator. Okay. Now, how we can call the value? By using next method. Okay, next of L1. So what will happen? Whenever I call this L1, it will return the one value at once. It is having all these values, but it will return one value at once. Okay, this we can call as a lazy evaluation. So for example, I want to see the memory size of this L1. Let's see. You can see it is having 152 bit, here 32 bit. There is a lot of difference in size. Okay, so this is very small. If we have hundreds of data, then how much it will impact? Let's say if I add few more values here. Some random values. Okay, so now the size might be updated. Okay, let's see. You can see this size is 264, but object size is, iterator size is same, 32. So which one is taking more memory? List is taking more memory. Okay. Now, whenever we create iterable sequence, it will take the less memory. Instead of storing all the values, it will store the object reference. Okay. Now, whenever we call the next method, it will return one value at once. Okay, this we can call as a lazy evaluation. Okay, so based on the demand, it will return one value at once. Okay, and it will remember current position, current position, current position. Okay, for example, here whenever I called next L1, what it will return? It will get 1. Okay, let me print. Okay, next print or next of L1. Okay, so this time it will print 1, second time 2. Okay, let's see 1 2. So I will reduce this list into small list. Okay, so if I call this time next, what it will do? What is the value? Okay, 1 2 3 5. Next L1. So what will happen up to this point? It will return the values whatever we have. 1 2 3 5 6 will be written. Okay, so even though if you return up to this one, it will remember the current position. Based on that, it will get the values. Okay, let's see. You can see 1 2 3 5 6. After all the values, even though if you call next method again, what will happen? There is no value to return. Okay, there is no value to return in the iterator object. Here it will throw the stop iteration exception. Stop iteration exception. Okay, it will throw the stop iteration exception. Okay, so whenever the values are completed, after that, if you call the next method, it will throw the stop iteration exception. Clear? Okay, so this is the uses of iterator. This is the way we can create the iterator. So iterator is a normal function. We can create the iterable sequences, and we can take any sequence like list, string, tuple, anything we can use. And it is more memory efficient, and it will follow the lazy evaluation. And we can use next method to call the iterator object. Iterator. Okay. So based on the demand, it will return one value at once. After all the values, if we call the next method, it will throw the stop iteration exception. That's it. Okay. Now, what about generator? So actually, iterator we can implement in classes. Okay. So there are two functions, iter and next methods we can use in the class. Even we can write our custom iterators. Okay. What about generator? Okay, let me come to it. Please. Okay. What about generator? So generator is a mechanism to create the iterators in a simple way. Okay. Generators is a mechanism create iterators in simple way. Okay, simple way. So here we can use yield keyword to return the values. Yield keyword to return the values. Okay, we can use n number of yield statements. Okay, yield statements. Here also we can call the generator object by using, we can call generator object by using next method. Okay, next method. Okay, and it will also throw the same stop iteration exception once values are done. Okay, Let's see. So compared to iterators, generators are more memory efficient because it will generators we can use to handle the large data sets with functions. Okay. So how we can define a function? By using the def keyword. Let's say I have a function something. So here I can use n value. Okay. So I put some condition here. I equals to something. Let's say 1 while I less than n. Yield I. Okay. I plus equals to 1. Okay. So just I am creating a function. So generally generators, we need to create a function. We have to work with functions only to create the iterable sequences in a simple way. Okay, with functions. Okay, here what we are doing, I have a function. It takes n as an argument. I declared an integer variable I equals to 1 while I less than n. So whenever the condition, if I call the function, let's say function, let's say 10. So what is the value of n? 10, right? So 1 less than 10. Condition true, it yield the value I will be 1, it will yield. Yield means it will return the value. Okay. And increment I will be incremented by 1. Again, coming to the condition 2 less than n, yield I value, increment I will become a 3, return I increment. Okay, in the same manner it will continue the until condition is false. Once condition is false, it will come out of the loop. Okay. Now, whenever we use yield keyword to return the values in any function, it will become a generator. Okay, it will become a generator. Sometimes iterators we can convert into as a generators, but all the iterators are not generators. Okay. So here, how we can call this generator? So whenever I call the function, what it will do, it will return the generator object. This we can call as a generator object. Whenever we call the generator function, it will return the generator object. If I print it, you can see. Let's. You can see it is a generator object. Whenever we call the generator function, it will return the generator object. How we can access the values here means again we can use the next function to call the generator object. So it will return one value at once based on the demand. You can see 1 is. So if I call it 2 times, 3 times, it will return 1, 2, 3, 4 something. You can see 1, 2, 3, 4. If I after all the values, what will happen if I call it again? So let's make it simple one. Let's say 5. So if I call it again, what will happen? It will throw the stop iteration exception. You can see stop iteration exception. After 4, if I call one more time, it will throw the stop iteration exception because already whatever the values we have within this one, we have written. So there is no value to return. So we'll get the stop iteration exception. Okay. Okay. So this is the way we can use the generators. So generally, generator we can use to create the iterable sequences. Okay. To create the iterators in a simple way. We can create a function and we can use yield keyword to return the values. Okay. And we can use n number of yield statements. Here we have simple one yield statement. Let's say if I create another function. So let's say sample. Okay, so nothing, just I'm going to yield 1, yield 2, yield 3. So if you guys remember, return where we are using return. Okay, like this we can use. This is very simple generator I have created to check the how many yield statements you can have. We can add n number of yield statements. Okay, here whenever I call this generator function, okay, so I can call the next method. Okay, so it will get the one value at once. Let's see. You see, only one value at once. If I call it again 3 times, it will give the 3 values, 1, 2, 3. Okay, so we can use any looping statements, or we can use n number of yield statements. Depends on our requirement. We are going to use yield statements. Now, generally, they will ask one question here. What is the difference between yield and return? Where we can use return? In a function, we can use return statement. Once return is executed, function will be completely executed, right? Terminated. Return only once it will execute in a function. But yield we can use in generators. We can use n number of yield statements. Okay, so that is the difference. I hope everyone is clear with this.
Yes, Madam.
Okay. So generally, in interview point of time, they will ask like create a Fibonacci series using generators. They will ask like this: how we can? What is a Fibonacci series? Fibonacci series, something like this, right? It will start from 0, 1, 1, 2, 3. I hope remember everyone, 8, right? So the sum of initially it will be 0, 1. Sum of 0 and 1, 1. Okay, again 1 plus 1, 2. 1 plus 2, 3. 2 plus 3, 5. 3 plus 5, 8. Okay, 5 plus 8, 13. This is the Fibonacci series. I hope everyone is remember. Okay, so here how we can create a Fibonacci series by using generators. Let's say okay, here initially values will be 0, 1, right? And I am declaring two variables 0 and 1. Okay, 0 and 1. Okay, so this is the way also we can declare multiple variables in a single line. Okay, it is equivalent to a equals to 0, b equals to 1. Okay, something like this. Now I can use condition here while or true. We can use condition will be true. Okay, here yield we are going to use yield keyword. It will return the a. Okay, so what is the purpose of yield? It will return the value, whatever the value we have. Okay, and so here if you guys remember, right, 0 plus 1, 1. Okay, 1 plus 1, 2. So I want to update the values by doing addition, right? How we can do that? Here we are using swap case, swapping the values. Okay, let's say a comma b equals to b comma a plus b. Okay, so exactly what we are doing here means, so initially what is the a value? 0. Okay, and what about b? 1 equals to what is the b value? 1. Okay, a plus b, again it is a plus b means 0 plus 1. Okay, so here I'm assigning a to 1, b to 1. Okay, so just I'm getting the swapping and assigning to the variables. So now a will become a 1, b will become a 1 again. Okay, so this is something like this. Okay, now a value is 1, b value is 1. Now Again, in the loop, next iteration, what it will do? Here, A 1, B, right? B, what is the value? B 1. B, A plus B 2, right? Already we have 1 1. So B is 1. A plus B means 2. Okay. So this time, so B value is A value is 1 and B value is A plus B 2. Okay. Now again, here you can see, right? B 2, A plus B means 1 plus 2 3. Okay. So the B is assigned to the A, means A is 1, sorry, 2, and B is 3. Okay. So like this it will continue the loop. Like this it will continue the loop. So it will yield the key A. Whenever it is one loop is completed, it will yield the A value. Okay. So this is the way we can create the Fibonacci series. Now after this, I can create an object of the generator. Generator object Fib series. Okay. Now whenever I call the function like next, okay, what it will return? The Fibonacci series start from here, right? A value will be returned. Let's see. You can see 0. If I call it again, 2 times, 0 1 1 will be there. You can see. Let's say now it will return some of the value. 0 1 1 2 3 5. So how many values it will return? How many values it will return? So if you guys understand the loop, what is the purpose of this loop? So condition always it is true, right? Always
Yes,
it is true. So if I call 100 times, it will get the 100 values. You can see. Let's run. You can see it will get the all the Fibonacci series because it is always condition is true. But whenever I want to control my statements, what we can do? Can we use for loop? Can we use this in a for loop so that we can, if I want to get only 5 or 10, I can iterate in a for loop. Okay. For example, for I in range, if I use 5, what it will return?
it will take only up to 5.
0 to 4. Okay. I value will be 0 to 4. But how many iterations will be there?
5.
5 iterations, right? So it will call the 5 times. Okay. Even without this variable also we can put, we are not using I, right? We can keep this placeholder as a variable. Okay. Now 5 times it will call the next method with the generator. Okay. Let's see. You can see 0 1 1 2 3. If I want more, if I put 10, it will get the 10 values. You can see 0 1 2 3 like this. So this is the way we can use generators. Okay. I hope everyone is clear with this. Okay. Let's jump into the decorators. So what is a decorator? So normally decorator is a function to add additional features without modifying the existing functions, without modifying the existing features or functionality to the functions. Okay. Let's see. It is a function to add additional features without modifying original functionality, original function, okay, without modifying original functions, okay. So here we can have a function as an argument, and we have inner function or wrapper function, inner function, okay. We have inner function, okay. Let's see how we can do that. And by the way, by using at symbol, we can call the decorator function on top of original function, okay, original function. Let's see. Let's say I have a small function def, let's say greet sample. So this is my normal function. So what it will do, just it will return hello, okay. Just it will, what it will return, it will return hello, okay. Now whenever I call this function, what it will do, just it will return hello. Without modifying this function, I want to convert into the uppercase this one. How we can do that? I don't want to disturb this function, but whenever I call this function, I want to get the uppercase letters. Let's see how we can do that. So we can use the decorator function here, decorator function, okay. And this function takes function as an argument, and it will have an inner function, okay. And inside this inner function, we can write the actual logic for decorator, okay. So here we can invoke the function, whatever it is returning this function, that I am converting into the upper, and I will return it, okay. And it will return the inner function, okay, like this. So decorator is a function, it will take function as an argument, and decorator will have a inner function. Inside this inner function, we can write the actual business logic, so whatever we want to do. So here we are invoking this function because this function is returning something that I want to convert into the upper case. Whenever we call this function, what it will do, it will return this hello that I am converting into the upper case, and it will return those value. And here, okay, this mistake, okay. So I am returning the inner function itself, okay. Whenever I apply this decorator function, whatever it is returning the function, it will return this one, okay. How we can apply the decorator on top of any function? By using at symbol, we can call the decorator name, okay. Now if I call the sample function, what it will do, let's print. What it will do, first it will execute the, whenever I call the function, first it will execute the decorator function, okay. So in decorator function, whatever it is having, this will be executed, okay. Decorator function will execute first, after that it will execute the normal function, okay. Let's run this one. You can see hello, it is executed hello. We have converted this, okay. If you want to invoke this function also, here we can invoke, just we can invoke, okay. So once you invoke this one, it will also execute it. Let's see. So here we can print this, print hello, okay. You can see hello is printed it is whatever the value is written, that will be converted into uppercase. Okay. So here maybe there might be some confusion, most of you. So here, which function is executed first? Either it is decorator function or sample function. So first it will execute the decorator function. Okay, because here we are returning the value, because of that we are not understanding. Let's see with the other example. Okay, so here I have decorator function. Maybe okay, decorator function. I can use decorator function 1. Okay, function as argument. I have an inner function, inner or wrapper, anything we can use, any name we can use. And here I will write the actual logic. Okay, let's say executing wrapper, something like this. And I can invoke the function. And I can return wrapper function itself. Okay. Now I have other function, sample 2. Okay. Print sample function. Okay, something like this. I can apply the decorator function. Okay, so which function is going to be executed first whenever I call sample 2? So first it will execute the decorator function. So it will print this line. After that it will execute the sample function. Let's see. You can see first it executed the decorator function. Okay, after that it will execute the normal function. So here we are returning the values, because of that we haven't seen this one. Okay, here also we are returning the values. If you use the print statement, we will come to know which function is executed first. Okay, so this is the way we can write the decorators, and we can apply the multiple decorators to the function. For example, I have other function here, or other decorator, like decorator function 2. Okay, instead of this, so here we have, right, the similarly I want to convert them into lowercase. One of the decorator is, I want to convert them into lowercase. So whatever the string we are providing, right, so it is a H is capital, remaining is lower. So whenever I apply the decorators, right, it will convert, one is uppercase, another one is lowercase. Okay, so first I have this. Okay, 2. Okay, so whenever I call this function, what will happen? First it will execute this decorated function, so it will convert into the uppercase, and second it will execute the function 2, it will convert into the lowercase. Let's see if I run this. Okay, let's run. You can see here 2. Okay, okay, still again it is because of return only. It is, if you use the print statement, it will be, or we can come to know what exactly it is working. Let's see with print statements. Okay, this is decorator function 2, and I'm calling here something we can say hello decorator function 2. Okay, something like this, decorator function 2, and I'm invoking function. So I'm applying the decorator on top of this function. So decorator function 1, decorator function 2. Okay, let me comment out all this. So I have decorator function 1 and function 2, and I'm calling those decorated functions on top of my sample2 function. Okay. So whenever I call this sample2 function, so first which function is going to be executed? Decorator function 1, it will execute. After that, decorator 2 function will be executed. Okay, let's see. You can see hello executing wrapper function, hello executing decorator function 2, and sample function. You can see first is executed this function decorator. This is a second decorator executed because of this order. Whatever we provide in the top, that will be executed first. Okay, so this is applying the multiple decorators to the same function. Okay, now the same decorator we can apply to the multiple functions. Okay, for example, I have function here sample 3. Okay, so I can apply this decorator to this. I can apply the same decorators like this. We can apply multiple decorators to the same function, and we can apply the same decorator to the multiple functions. Okay, like this. So this is the way of using decorators. Okay, so generally these are the custom decorators what we are writing, but we have inbuilt decorators also. So going forward, you will come to know what are the inbuilt decorators we have. For example, class method, static method, abstract abstract method, property class, property, data provider. So these are some of the inbuilt decorators we have in Python. Okay. Going forward, you will see all these things when we are going to talk about the object-oriented features. Okay. I hope everyone is clear up to this point.